So we'll discuss what are ER diagrams and how it can be used in our RDBMS, Relational Database Management System. So we are going to deal with a lot of data as a database administrator. So before that, we need to know how the data is stored inside the RDBMS. In RDBMS, data is stored in tables, and these tables are all collected together as a database. So this is a database, and inside this we have multiple tables, and each table will be related to other table. In an organization, there will be multiple departments. I'm just giving an example. In an organization, there will be multiple departments, and all the departments are part of the same organization. So there may be relations between, or the relations or dependencies between one department to another department. So for that, there should be relations between the department, and we are going to see how the relations can be set up. So for setting up the relations, we are going to use entity relationship diagram, and entity is any real world object. So it can be a table or a user, a person, anything, we call it as an entity. So here it is. So entity can be a object, person, or a class. So it is a real world object actually. And there will be properties for the entity, and we call it as attributes of the entity. And we are going to set up relation based on entities and attributes. And usually in ER diagram, entity is represented in the form of a rectangle. So a simple rectangular box represents the entity. So here student is one entity and subject is also an entity. And the relationship between the entities is represented in the form of a rhombus or a diamond box. So it is a relationship, and it can be a strong relationship or a weak relationships. So if it is a weak relationship, it is represented with double rhombus box. And every entity will have attributes. So as every person will have a few attributes, every entity will also have an attribute. For example here, so if you consider book as one entity, so a book has an author and the date of publish as well, when it was published. So there may be some other attributes also, like in which language it is published, and in which are all the countries it is published. There are different attributes for a book. So for every entity there will be attributes, and attribute is represented in the form of ellipse. So we are not going to use this in database administration, but it is good to know about all these things. So these are the basics of our data DBMS. And we have discussed an entity is represented in the form of a rectangle. So there will be weak entities also. That is, the entity that is dependent on another entity, we call it as a weak entity. And it is represented in the form of double rectangle box. For example, installment is part of a loan. So installment itself cannot be a direct entity. So it is a weak entity here. And as we discussed, there will be many attributes to the entity, and there will be one entity through which we can that will be the main attribute for the entity, and we call that entity as a key attribute. And key attribute are represented by underlining the attribute name inside an ellipse. And derived attribute for an entity. So this attribute is derived from another attribute. For example, date of birth will be one attribute for an entity of a student, and age of the student can be derived from the date of birth only. So this is an derived attribute, and derived attribute is represented in this way. So inside the ellipse, there will be one more ellipse, and that ellipse will be in a dotted format. So usually the architects should require all these things. So to set up the environment. And multi-valued attribute, and this attribute that has multiple values. So for one attribute, there can be a multiple values which can be represented in the form of double ellipse. And composite attribute. So composite attribute will have an attributes for itself again. So there will be different attributes for that same attribute. We will see with examples again. So as we discussed, entity is a real world object which has attributes, and there are different types of attributes as we have discussed now. And the relationship between the entities is represented in the form of rhombus or the diamond box. For example, here employee and department are two entities, and these two are related with works for, that is employee works for a department. So if anyone has any doubt at any time, you can stop me anytime. And as discussed, loan and installments are two entities, but installment is dependent on loan entity. So installment is a weak entity here. And attributes is the characteristics or properties of an entity. So if you consider student as an entity, so it has attributes like name, address, ID of the student, age, and we can also have department, class. So all these are the properties of an entity, and we call them as an attributes. And key attribute through the attribute through which we can uniquely identify, or we can identify the entity, we call it as a key attribute. So as discussed, it will be represented by underline. So composite attribute, so as we discussed, an attribute that has more attributes to itself. So address is one of the entity here. So in address, there are again all these values should be included. So address should have a city, address value should have state, and pin code or zip code cell. And we call the address as a composite attribute here. And relationship we have seen already, and this is one more example. Teacher and student are two entities, and these two entities are related in the form of teachers. So the teacher teaches to the student, and there can be different types of relation that exist between the entities. So they are one-to-one, binary, recursive, and ternary relationship. So if it is a binary relationship, it is a one-to-one relationship. So student is enrolled in one course, and there can be a one more relationship, like one student can be enrolled in multiple courses also. So there is possibility of student enrolling in multiple courses. And many to one relationship, in this case, many students will be enrolling to one course, and there is many to many relationship. So many students are enrolled into many courses that is available in the institute. And recursive relationship, so an entity that is having relationship with itself. So for example, let's consider employee as an entity. So employee is managed by one more employee. So one employee manages multiple employees, and here employee itself is managing, and if and employee itself is managed by. So this is a recursive relationship with itself. And next is a ternary relationship. So it is a three-way relationship. So it involves three entities at least. So in binary relationship, so we have two entities. Uh, we should have at least two entities, and in binary relationship, we have multiple relationships: one to one, one to many, many to many, and one to many. And we have one more relationship called the recursive relationship, and we call this as a single relationship also. That is a relationship for the entity with itself is called as a recursive relationship. And relationship between two or more entities, it is a ternary relationship. It involves three entities. So here the company operates in sector producing some products. So these three are related here with a different attributes. And the enhanced ER model is necessary for proper modeling of data inside the databases. And this modeling includes three categories. They are generalization, specialization, and aggregation. So the generalization is a bottom-up approach. So here we are having multiple entities and we are generalizing it into a single entity. So we have account types called savings and current accounts, and it is generalized into a bank account. So here we call this entities as a subclass, and these are the superclass. And we have specialization. Entity, it is divided into specialized cases. So if you consider student as one entity, a student can be an old ex student or it can be a current student. So getting down from the top, we call it as a specialization, and for bottom up approach is a generalization. And aggregation, in aggregation we'll have one entity, and inside that entity there can be an another relationship also. So if you consider this example, the visitor visits an institute to get the information both about the center and the course as well, both about the institute as well as the course. So the student is going to inquire these both details from the institute itself. So student will not just come to get to know about the course or come to get to know about the center only. So here this combined together, it is an entity, and this is called as aggregation. So based on this ER model, relational database management system is modeled, and RDBMS is introduced by a computer scientist called EF Card, and he has given some rules to be a successful relational database. For a successful relational database, this database should follow the rules that is provided by EF Card. And we have a total of 13 rules, and it starts with rule 0. So for a database to be a successful RDBMS, so it must be able to manage database entirely through relational capabilities. So as we have discussed now about different types of relations, so the database has to be managed through relational capabilities. That is the rule 0. And rule 1 is the information rule. So in the information rule, the data has to be stored in the form of rows and columns inside a table. So it is in the table we are going to store the data, and the data will be stored in the form of rows and columns. And guaranteed access. So the data has to be accessible. So regardless of, here we are not considering the security as of now. So the data that is stored in the table should be atomic and it should be accessible. And for this, we should have a table name, primary row or primary key, that is we should have rows and we should have columns. And there can be null values also that can be stored. If you consider the constraints, null values is not possible. Without considering the constraints, null values should be able to store in the tables, and it can have a different meanings. It can be a missing data, not applicable, or no value. So for all these things, we are going to use a common column value called null value. So we are going to store the data and the database information, store the data in the database, and the database information also should be stored in some catalog, and it should be accessed in the same way as the data is accessed inside a database. And to access this, we are going to use a language. So it is the same language that we have to use to access database catalog as well as the data inside the database. That is the rule number 4 by EF code. And to access all these things, we should use a powerful and well-structured language. And we are going to use a language called SQL. It is a structured query language. And we should not be able to access data inside the databases without using this language. Then it is a violation if you are able to access the data without using the language. And if a database is violating any of this rule, and it is not a candidate for our DBMS. So all these rules has to be satisfied for the database to be a successful relational database management system. And we can create views on a table, and the views has to be updatable. So we should be able to update the views that is created on the table. And we should perform all these type of operations on the relations, like insert, delete, and update operations should be able to be performed. And also we should be able to perform union and intersection and minus operations on the data. And physical data independence. So some file supporting the table is renamed or moved to another disk, it should not affect the application. For the application, it is only table that is applicable. So the table data is stored actually in a physical files. It is not required for the application. And logical data independence. A table can be split up into multiple views as well. But when the application accesses the table information, they have to get the information as if they are going to get it from a single table. And there can be many constraints that can be applied on a database. And the database should be able to enforce its own integrity. So rather than using a different programs, that is RDBMS should be independent of the front end. So the structure and the way the data is stored inside the database should be independent of the front end. So actually the database is a backend where the data is stored, and in the front end there can be different applications that uses the database for storing and accessing the data. And RDBMS should be independent of the structure of the front end. That is, front end should not affect the way we store the data in the backend. And distribution independence. So we can store data in multiple locations, but for the application, it should resemble like they are getting the data from a single location only. So nowadays the database can be geographically distributed by using cloud environments. So the cloud data centers are located in multiple locations. So if one location is down, so the cloud providers will bring up the data in some other location. But for the application who is accessing the data from office or from their home, so it is like they are getting it from a single location only. And non-subversion rule: if low-level access is allowed to a system, it should not be able to subvert or bypass the integrity rules. So if you provide some access to the system, some users, so the user should not bypass the integrity rules that is already set up on the system. For example, if encryption is set up on a database, on a table, and even though the user has his read permission to read the data from the table, if it is an encrypted without proper certificates, the user should not be able to access the data. So all these rules has to be followed by a database to be a relational database management system. And these rules are set up by EF card, and he also designed a relational database management system based on these rules. And our SQL Server is a relational database management system. So apart from SQL Server, Oracle is also an RDBMS. So in our relational database management system, the data is stored in the form of tables, and inside the tables, it is stored in the form of rows and columns. And the relations, we call it as a tables, and the rows inside the tables, we call it as tuples. and the attributes are called as a column. Table is a collection of data elements that is arranged in the form of rows and columns. So this is an example of a simple table, and we are able to see it in our server as well. So this is a database. Inside the database we have tables, and inside the tables the data is organized in the form of rows and columns. This table has 16 rows and there are 4 columns in it. And there are tables with multiple columns as well, multiple columns and rows. So this table has more than 1000 rows, and we have multiple columns in it, and there are different types of data that is being stored in each column. So in RDBMS, the data is stored in the tables in the form of rows and columns, and we call the row as a tuple and attributes as a columns, and table is a relation. And the table should also satisfy relational integrity constraints. There are 3 types of constraints: key constraints, domain constraints, and referential integrity constraints. So for key constraints, there are certain type of rules that needs to be followed. For example, some key columns should not hold the value of null values. There should be some or the other value for the key column, and it should not be null. And domain constraints, it is like, for example, if you consider a phone number or a mobile number, it should not exceed more than 10 digits. So it should have value less than 10 digits only. It is a domain constraint. And referential integrity constraint, if there is a relationship between one entity and another entity, so the other entity also should exist for a referential integrity constraint to hold true. So without 2 tables, we cannot set up a relation with another table. Comparing the ER diagrams that we have discussed and with the relational model or DBMS. So entity is an table here. Entity in ER model is changed into a table, and the attributes of the entity is the columns. And the values that we are storing for these attributes, these are called as row values or tuples. And relationship between becomes a relationship table. So we have 2 entities here, teacher and student. So one more additional table can be created by using these 2 entities, teacher and student, and we call it as a student teacher table. So that is, we can store the information about both student and teacher in a common table. So this is the basic information about RDBMS. So if you go deep, we will get to know about more details like what is primary key, what is foreign key, all these things. So not required as of now. So these are the basic things that we need to require, and we need to know about SQL Server, SQL language as well. It is a structured query language through which we interact with the RDBMS. And by using SQL, we can perform operations like DDL, DML, that is data definition language, data manipulation language, and data control, transaction control language. We call it as TCL, and data control language. So to store and access data from the SQL Server, we have to use a language called structured query language. And by using structured query language, we can perform operations like creating objects like tables, indexes, all those things we call it as objects. And into that we have to store data, and we store and update data by using insert, update, and delete statements, and we call them as DML statements. And creating and altering the tables, we use DDL statements, data definition language. So in data definition language, we can do create, alter, truncate, drop, and rename of the objects. And the data inside the objects is manipulated by using DML languages. For this, we use statement types like insert, update, and delete. And transaction control language. So if you perform any transaction, if you want whether the transaction to be committed or rolled back, we have to use the transaction control language for this. So if it is commit, we are going to permanently save the information modified by the transaction. So if you doesn't want the change to be modified, we can undo the change, and we can set up save point to save the information for a temporary purpose. And to grant and revoke the permissions on the objects or on the data, we use data control language. So by using DCL, we can grant and revoke the permissions. And to extract the information from the tables that is inside the database, we use select statement. So the basic objective of SQL Server is to store and retrieve data. So by using SQL, we are going to store data into the SQL Server, and we are going to retrieve the data from the SQL Server. So SQL Server is an application from a database application from Microsoft, which follows our DBMS rules. So Microsoft SQL Server is a relational database management system where the data is stored in tables. Inside the tables, it is stored in the form of rows and columns. And let's get into the details about SQL Server now. So we have got some basics set up now. So let's start discussing about SQL Server. So how it has started and how it has evolved over the years, we'll discuss now with history of SQL Server. Microsoft SQL Server is a database application from Microsoft, and there are different database applications available in the market like Oracle DB2, uh, SAP HANA. So there are different types of databases, and Microsoft SQL Server is one of the database applications similar to that. And it follows the relational database management system, that is RDBMS. And uh, SQL Server was first introduced in the year 1988, and it is introduced in collaboration with Microsoft and Sybase. So it was a joint venture of Microsoft and Sybase in 1988, and later it was parted. They both parted their ways, and Microsoft has released their own version, the first own version in the year 1994. It was SQL Server 6.0. And the next release was SQL Server 7.0, and it was in the year 1998. And there were many modifications from 94 to version 6.0 to version 7.0. So anyways, both these versions are deprecated now. It is not being used currently. And from the year 2000 onwards, uh, Microsoft has started appending the year name along with the version release. And first in that list is SQL Server 2000. And there were many enhancements from 7.0 to SQL 2000. So the OLAP services was in SQL Server 7.0, and it was replaced with analysis services, which we are still using, that is SQL Server Analytical Services. And till 2000, SQL Server 2000, so we were using different tools to perform different tasks. So we should have an idea of which tool to use to perform a certain type of task previously. But all the different tools are integrated together, and it was introduced as a SSMS. We call it as SQL Server Management Studio. Like all the managing operations can be performed from the single tool. So it was introduced in 2005, which has eased the way we work on the SQL Server. So even now we are using SSMS to connect to the databases or the SQL Server and to perform our tasks in it. And also SQL Server Integration Services was first introduced in SQL Server 2005 version. Previously, it was called as a Data Transformation Services. So it is an ETL tool for extracting, transforming, and loading of data. Previously, it was Data Transformation Services, and it was transformed into SQL Server Integration Services. And the next release is SQL Server 2008. So there are many auditing options included in SQL Server 2008 version, and also the backup compression is also introduced. So we, as a database administrator, we will be dealing with very large size databases, and we should also take the backup of databases. By taking the backup of very large size databases, it is going to occupy additional space. So we have an option of compressing the backup files from SQL Server 2008, which was not available in the previous versions. And the next release was SQL Server 2012. So in 2012, a new high availability feature called always on high availability was introduced. So previously it was mirroring and it was enhanced to into a always on high availability. And it has there were more enhancements made on always on high availability in the later versions for the ease of maintenance and for the ease of setting up. And the next release is SQL Server 2014. From 2014 onwards, Microsoft has started using cloud premises for storing the data. So we can store the data in Azure cloud storage as well. And there were enhancements made on the features that was introduced in the previous versions, like always on column store indexes. There were many enhancements made to them. So this is till 2014. There are still more releases from Microsoft. So now let's learn about the other versions of SQL Server. So after 2014, there was another release called SQL Server 2016. So the next release after 2014 was 2016, and there are many features for every version release. There will be many new features will be added, but in a database administrator perspective, not all the features are required for us. So in 2016, the new features as part of database administrator perspective is security. So here we have new features like dynamic data masking, row level security, and always encrypted. So these new by using these new features, we can enhance the security of data that is stored in the SQL Server. And these all other features are for developers and other users. And the next release is SQL Server 2017. So soon after 2016, 2017 was also released. So it is having the same features as 2016, but only additional things in the 2017 is 2017 can be installed in Linux and Ubuntu systems as well. So previously till 2016, starting from SQL Server 7.0 and 6.0, we can install SQL Server only in Windows operating systems. So we are not able to use it in Linux or Ubuntu systems till 2016. But uh, Microsoft has started supporting SQL Server in Linux and Ubuntu systems as well from SQL Server 2017 onwards. And many more enhancements from the developers perspective, like Python language support is introduced, Docker containers can be used, and enhanced query processing is also introduced in 2017. So the query executions would be faster compared to the previous versions. And the next release and the latest release in the market is SQL Server 2019, and it is developed more in considering the developers and considering the machine language and artificial intelligence. But compared to 2017, we have intelligent query processing, which enhances the query performance, and also in-memory database. Like we can create a database completely inside the memory, so which is easy to access. The speed of accessing the data will be quicker by using in-memory database. So these are the new features available in 2019. And with every version, there are different editions released by Microsoft. It depends on licensing costs and the feature availability. So with every version, they will release different editions like Enterprise, Standard, Express, and Web editions like this.